Did you know the internet flows through thin glass tubes? Would you trust your data to sharks? Tell us below. These cables use pulses of light to carry your messages. They stretch for thousands of miles across the crushing abyss. Thick steel armor protects the delicate glass from extreme pressure. Specialized ships spool these massive cables onto the ocean floor. Ship anchors are surprisingly the biggest threat to global connectivity. Robotic submersibles dive deep to splice broken cables back together. Your video buffers because light travels fast but distance matters. New cables are constantly added to support our growing needs. Ultra-thin glass strands carry light pulses across the abyss. Information travels near light speed through these long, dark tubes. Steel wires protect fragile glass from crushing deep sea pressure. Specialized ships spool these cables onto the ocean floor slowly. Engineers map underwater canyons to avoid jagged rock formations daily. Signal repeaters boost data strength every 100 kilometers or so. Sharks occasionally bite cables, mistaking them for tasty electric snacks. Heavy plows bury cables under sand to prevent anchor damage. These hidden lines link every continent into one global network. Your emails and videos flow through these silent ocean corridors. Data travels through glass fibers thinner than a human hair. Lasers bounce perfectly inside these strands, using total internal reflection. Copper tubes and plastic jackets protect these fragile glass cores. These cables must withstand immense pressure on the ocean floor. Steel wires provide the structural integrity needed for deep deployment. Some sharks occasionally mistake cables for prey, causing minor issues. Electronic repeaters amplify signals every 100 kilometers across the basin. Copper conductors carry high voltage to power these underwater repeaters. Engineers map the seabed to avoid sharp underwater mountain ranges. This complex engineering keeps the entire world connected every day. Inside these cables lie glass fibers thinner than human hair. Lasers pulse data through glass at nearly the speed light. Light bounces off the glass walls to travel vast distances. Eventually, the light signal weakens as it travels across oceans. Repeaters placed periodically amplify signals to keep data flowing smoothly. Copper layers carry high-voltage electricity to power these repeaters. It is ironic that global communication relies on brittle glass. Steel wire armor protects the delicate core from deep pressure. A thick plastic shell prevents corrosive seawater from entering inside. This rugged construction keeps our digital world connected every second. Tiny glass strands transmit data via pulses of rapid light. Information travels across oceans at nearly the speed of light. Cables endure immense pressure miles below the dark ocean surface. Steel wire layers protect delicate cores from crushing water weight. Curious sharks sometimes mistake these cables for tasty underwater snacks. Electronic repeaters amplify signals to ensure data stays perfectly intact. Complex network maps show how continents share this digital infrastructure. The ocean floor is surprisingly rugged, with mountains and canyons. Engineers carefully choose flat routes to avoid damaging the cable. Billions of bits flow silently while we browse the web. Inside these thick cables sit hair-thin strands of glass. Lasers pulse binary data through these glass fibers every millisecond. Light bounces perfectly inside the core without ever escaping out. Even pure glass, eventually, dims the signal over long distances. Submerged repeaters amplify these fading light pulses across the abyss. Copper shells feed electricity to power these deep-sea stations. It is funny how modern internet relies on ancient copper. Engineers wrap everything in layers of protective steel and plastic. The structure must withstand extreme crushing pressure on the floor. These hidden tubes keep the global digital world connected daily. Data travels through glass fibers thinner than a human hair. Light pulses bounce off internal glass walls at incredible speeds. Multiple layers of plastic and copper protect these delicate strands. Thick steel wires prevent the cable from snapping under pressure. Anchors are the biggest threat to these critical global links. Sharks occasionally mistake the vibrating cables for tasty deep-sea snacks. Engineers monitor signal strength constantly to find any minor breaks. Repeaters amplify light signals every few miles to maintain integrity. Remotely operated robots perform delicate surgery on broken ocean cables. Cables are laid on flat planes to avoid jagged trenches. Cables face extreme pressure miles down on the dark floor. Sometimes, sharks mistake these thick cables for tasty deep-sea snacks. We wrap them in steel wire to stop hungry biting. Special plows bury cables under sediment to keep them safe. Hit like if you find this oceanic engineering work impressive. Ship anchors are actually the biggest threat to these lines. Hit the subscribe button and press the bell icon to get updates. Engineers weld tiny glass fibers with incredible microscopic surgical precision. Repeaters boost the fading light signals across vast ocean distances. Sensors monitor every pulse of data crossing the silent abyss. Cables survive extreme pressure miles down on the ocean floor. Thick polyethylene coatings prevent water from corroding the copper cores. Steel wires provide tension strength against shifting tectonic ocean plates. Light pulses travel through hair-thin glass fibers inside cables. Repeaters amplify fading signals every 50 miles along the line. Sharks occasionally bite cables, mistaking them for tasty electric prey. Robots bury cables under sediment to avoid fishing net damage. Dragging ship anchors remain the biggest threat to global connectivity. Multiple redundant paths keep your internet running during cable breaks. Billions of data packets flow silently beneath the rolling waves. These cables are surprisingly thin, roughly the size of soda. Light pulses travel through glass fibers thinner than human hair. Copper layers protect signals while thick plastic shields the core. Deep sea cables withstand immense pressure near the ocean floor. Repeaters amplify fading light signals across thousands of ocean miles. Most internet traffic traverses these silent, dark, underwater superhighways daily. Underwater landslides occasionally snap these vital data links without warning. Heavy ship anchors accidentally cut cables near crowded coastal ports. Sharks occasionally mistake cables for prey, causing minor connectivity hiccups. Specialized ships patrol the seas, fixing broken lines around clock. Cables face extreme crushing pressure on the dark ocean floor. Steel wires protect fragile glass fibers from shifting tectonic plates. Polyethylene coatings insulate delicate signals against freezing abyssal water temperatures. Sharks occasionally mistake vibrating cables for large, tasty deep-sea fish. Repeaters spaced every 60 miles boost signals across vast distances. Copper conductors carry high-voltage electricity to power these repeaters. Engineers carefully map routes to avoid jagged, unstable underwater mountains. Specialized ships plow trenches to bury cables safely beneath sediment. Remote-operated vehicles descend to splice broken lines underwater daily. Pulses of light carry petabytes of data across entire oceans. These massive cables rest silently on the cold ocean floor. They connect entire continents through thin strands of pure glass. Information travels as light pulses moving at incredible rapid speeds. Thousands of meters down, water pressure is crushing and immense. Steel wire layers protect the delicate fibers from shifting currents. Sometimes, sharks mistake these humming cables for tasty deep snacks. Dedicated ships must retrieve broken sections from the dark abyss. Engineers splice glass fibers together to restore your global internet. The entire digital world depends on these hidden underwater threads. The facts remain, and the search for truth continues.